Few individuals in human history have changed the way we understand the world as profoundly as Isaac Newton. A mathematician, physicist, and philosopher, Newton laid the foundation for classical mechanics and revolutionized science in ways that still shape our lives today. From discovering gravity to formulating the laws of motion, his work transformed humanity's view of the universe. Isaac Newton was born on January 4, 1643, in the small village of Woolsthorpe, England. His arrival into the world was anything but ordinary. He was born prematurely and was so tiny that his survival was uncertain. Tragically, his father had died before he was born, leaving Newton to grow up without ever knowing him. When Newton was just 3 years old, his mother remarried and left him in the care of his grandparents. This separation had a deep emotional impact on him, contributing to his solitary and introspective nature. As a child, Newton often preferred isolation, spending his time building mechanical models and experimenting with objects rather than socializing with others. Despite a slow start in school, Newton's intelligence soon became evident. He developed a strong interest in mathematics and the natural world, setting the stage for his future discoveries. Newton attended University of Cambridge, one of the most prestigious institutions in the world. There, he studied mathematics, astronomy, and natural philosophy, the early term for science. During this time, the ideas of earlier thinkers like Galileo Galilei and Johannes Kepler were beginning to challenge traditional beliefs about the universe. Newton absorbed these ideas and began developing his own theories. However, his education was soon interrupted by a devastating outbreak of the Great Plague of London. In 1665, Cambridge University temporarily closed due to the plague, forcing Newton to return home. What might have been a setback for others became the most productive period of his life. During this time, often referred to as his Annus Mirabilis, or Year of Wonders, Newton made groundbreaking advances in several fields. Mathematics. He developed the foundations of calculus. Physics. He began formulating his laws of motion. Astronomy. He explored the concept of gravity. Optics. He studied the nature of light. In just a few years, Newton accomplished what many scientists could not achieve in a lifetime. One of the most famous stories associated with Newton is the falling apple. While sitting in a garden, Newton observed an apple dropping from a tree. This simple event led him to question why objects always fall toward the earth. From this observation, Newton developed the theory of universal gravitation, the idea that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. This revolutionary idea explained not only why objects fall, but also how planets orbit the sun and how the moon stays in orbit around the earth. Newton's 3 laws of motion are among his most important contributions to science. They describe how objects move and interact with forces. Law of inertia. An object will remain at rest or in motion unless acted upon by an external force. Law of acceleration. The acceleration of an object depends on the force applied and its mass. Action and reaction. For every action, there is an equal and opposite reaction. These laws became the foundation of classical mechanics and are still used in engineering, physics, and everyday life. Newton also made major contributions to the field of optics. At the time, many believed that white light was pure and indivisible. Newton proved otherwise. Using a prism, he demonstrated that white light is actually composed of a spectrum of colors. This discovery fundamentally changed the understanding of light and color. He also invented the reflecting telescope, which used mirrors instead of lenses. This design improved image clarity and is still used in modern telescopes today. In 1687, Newton published his most famous work, Philosophiæ Naturalis Principia Mathematica. Often simply called the Principia, this book laid out the mathematical principles of motion and gravity. It provided a unified explanation of how objects move both on Earth and in space. The Principia is widely regarded as one of the most important scientific works ever written. It established Newton as one of the greatest minds in history. Newton's success brought him fame and recognition. He became a leading figure in the scientific community and was elected president of the Royal Society. In 1705, he was knighted by Queen Anne, becoming Sir Isaac Newton a rare honor for a scientist. In addition to his scientific work, Newton also served as warden and later master of the Royal Mint, where he helped reform England's currency system. Despite his brilliance, Newton's life was not without conflict. One of the most famous disputes in scientific history was his rivalry with Gottfried Wilhelm Leibniz over the invention of calculus. Both men developed similar mathematical concepts independently, but the question of who deserved credit led to a bitter and long-lasting feud. Newton was known to be highly protective of his work and could be secretive and defensive when challenged. Beyond science, Newton had a deep interest in alchemy, religion, and philosophy. He spent years studying ancient texts and attempting to uncover hidden truths about the universe. He wrote extensively on theology and believed that understanding nature was a way to understand the divine. This combination of scientific rigor and philosophical curiosity made Newton a deeply complex figure. Isaac Newton died on March 31, 1727, but his influence continues to shape the modern world. His work laid the foundation for future scientists, including Albert Einstein, who later expanded on Newton's ideas with the theory of relativity. Newton's laws are still used today in space exploration, engineering and construction, physics and education, technology and innovation. His ability to explain the natural world with mathematical precision marked the beginning of modern science. Isaac Newton was more than just a scientist, he was a visionary who transformed humanity's understanding of reality. From the fall of an apple to the motion of planets, his discoveries revealed the hidden order of the universe. His legacy reminds us that even the simplest questions can lead to the greatest discoveries. As Newton himself once said, "What we know is a drop, what we don't know is an ocean."